Okay, gang, here we go. Number 2, use the remainder and factor theorems. So we're going to learn those two things. First of all, what is the remainder theorem? Remainder theorem says when you have a polynomial p of x and you divide by x minus c, then the remainder r is p of c. Whoa, that's a surprising fact, isn't that? Came out of nowhere. It seems like that's crazy. What does that mean? That means like if you were to run your synthetic division by x minus c, which we saw in the last video, then you look at that last column, which gives you the r. It turns out that's the same thing as if you were to just plug in c to your polynomial function. You get the same result. Which also means, and that's kind of the note down here, that if I wanted to evaluate p of c, then one alternative method I have is to actually run the synthetic division, and then the remainder, the last column, gives me the evaluation at c. Is that cool? Okay, now note though, this only works when you're dividing something of the form x minus c. Or we saw earlier that's equivalently you could say x plus c. But we're going to focus on x minus c actually. That's the form. That's the standard form. Note also that there's no squared terms, right? And there's no other coefficients of the x. It's got to be just 1. That's the same thing, same conditions we saw for the standard method of running the synthetic division algorithm. So we're only dealing with x minus c as divisors. Now, I think this is such a cool theorem, and the proof is really straightforward and easy. So let me just show this to you real fast, justification for why it's true. So let's think now. Let's take my polynomial, right? Let's say I'm dividing it by my x minus c, right? And then when you divide something, some polynomial, we saw through the division algorithm, you get a quotient polynomial, right? Plus some remainder polynomial. But in this case, because I'm dividing by x minus c, that's a degree 1 polynomial. That means the remainder should have degree less than that. So it has to have degree less than 1. And that means the only option is to have just degree 0. Degree 0 just means that it's a number. So it's actually not really even necessary to write r of x. This is just a number. Number r. It might be 0, but that's still just a number. And remember, there's an alternative format, right? It says, okay, if I divide, what happens? That means p of x is the divisor times the quotient plus the remainder, right? Remember this fact from the division algorithm, right? Okay, so now check this out. What happens if I plug in c into this function, this polynomial function? So if I take p of c, what is that? That means I'm going to replace every occurrence of x with c. That means x is going to become c here. So c minus c times q of c plus r. But look at this. C minus c is 0, right? So because this guy is 0, 0 times anything is just 0. So this whole thing becomes just 0. That thing is gone. Which leaves me with p of c equal to r. And that was the whole point of the remainder theorem, to say that PC is equal to r. Isn't that cool? Okay, let's move on. Pause your brain. Pause to rest your brain. Let your brain recalibrate itself. I'm going to erase this because you can always rewind the video if you wanted to see it again. Okay, let's look at the factor theorem now. Factor theorem. Factor theorem says C is a 0 of P of X if and only if. If and only if means if it is, then the right side is true. And if the right side is true, then this is true. So C is a 0 of P of X if and only if X minus C is a factor of P of X. Or said another way, what does it mean for C to be a 0? It means that if you plug in C into the function, you get 0. So P of C is 0 if and only if P of X is Q of X times X minus C. So that means that there's no remainder, in other words, right? And that follows directly from the remainder theorem, right? What does it all mean? What does it mean to be a 0? It means that when you plug in that value, you get 0. And if you get 0, well, then the remainder is 0 because those are the same, right? R is P of C. So that's all the factor theorem says. Specific case kind of what happens from the remainder theorem. But check out this implication. Why is that important to us? Why do we care? This theorem means you can apply synthetic division to determine if something is a factor of a polynomial. Because if it's a factor of a polynomial, if that x minus c is a factor, that means it divides the polynomial perfectly, then the remainder is going to be 0. And you can also go the other way. You can also go the other direction too. If you evaluate the polynomial and you get p of c equal to 0, that means that x minus c is a factor as well. So you can go in both directions if you want. Okay, and then you can use synthetic division to actually get the factors. The factors would be the quotient and the divisor. All right, let's try question 6 to 10 now. Okay, I'm going to start with 6. Okay, 6 has a few questions in one. Part A, B, and C. It says use synthetic division or anything to find the function value. Okay, and then check the value by evaluating. So there's two ways that we could evaluate these. Before we've done this kind of evaluation before, right? F of 1 just means you plug in 1 here, plug in 1 there, and see what you get. But this is saying that I could actually do this factor theorem and evaluate by treating this like my c in synthetic division. So that means the 1 goes here. I write my coefficients here. X cubed is a coefficient of 1. There's no x squared terms. 5x minus 11. Run the algorithm. This comes down. 1 times 1 is 1. Add together. 1 times 1 is 1 again. Add together. 1 times 6 is 1 times 6 is 6. 6 times negative 11 is negative. Oh, sorry. What am I talking about? Negative 11 plus 6, I mean, is negative 5. Right? So this here is the remainder. That means that f of 1 must have been negative 5. Okay, let's check. Let's check. So f of 1 is 1 cubed plus 5 times 1 minus 11, which is 1 plus 5 minus 11, which is 6 minus 11, negative 5. So see how we get the same thing? That's what the remainder theorem said should happen. All right. So we're just going to do that for A, B, and C. That's all. Repeat that process. Okay, that was part A. Part B. This is 6B. Negative 1. So negative 1, right? That goes in the little box. Coefficients are 1, 0, 5, negative 11. Draw my line. Bring this first guy down. 1 times negative 1, negative 1. Add together negative 1. Negative 1 times negative 1 is positive 1. Add together I get 6. 6 times negative 1 is negative 6. Add together I got negative 17. So this is my answer. F of negative 1 should be negative 17. Let's check. Negative 1 cubed plus 5 times negative 1 minus 11. That's negative 1 minus 5 minus 11, negative 17. Checks out. Nice. And then one more. Oh, a half. Really? Why do we need fractions? Okay, it's negative a half. And I guess the reason for this is to show you it still works, even with fractions. So 1, 0, 5, negative. Okay. Line, bring it down. That's 1. 1 times negative a half. Add it together, negative half. Multiply those, I got positive a fourth. Add together, I got 5 and a fourth. Or I can say, what was that? 5 times 4, 20, 21 fourths. Multiply together, I got negative 21 eighths. Now add together, 11 is going to be 88 eighths. So negative 88 minus 21, 88, 90, 109. Negative 109 eighths. Yeah. Okay. I guess we should check. F of negative a half. Negative half cubed plus 5 times negative a half minus 11. That's negative 1/8 plus negative 5 halves minus 11. Change the common denominators. Negative 1/8. That's 5 times 4, negative 20 over 8. And then minus 88 over 8. 88, they're all negative, so 88, 98, 108, 109. Negative 109 eighths. Okay, sweet, worked out. Okay, so there you go. Remaining theorem, ran the synthetic division. The remainder was the same as the evaluation. So that's just to show you, you can do that. Yeah, this is why I say, I don't really feel like, for that purpose, it's really that necessary. But it's a little nifty trick. It is a little nifty trick. And if you don't want to evaluate maybe, or you want to be double sure that you got the correct answer, then it's kind of nice to do, I guess. But yeah, I think the more important use, more important use I think is over here. What questions are I supposed to do right now? 6 through 10? Oh, 6 through 10. Okay. I'm thinking I might break this one up. Should I break this one up? Or should I break up the last one? Okay. Let me just keep working for now. So we'll do at least 7 and 8 right now. Okay. Check that over here. Oh, okay. Yeah, this is pretty easy. Use a factor theorem and synthetic division, or just plugging in, to determine whether the second polynomial is a factor of the first. So why don't I just I'll do it one way each, okay? So I'll do once using synthetic division, and then for number 8, I'll do it by plugging in. So I'm trying to check if x plus 3 is a factor of this thing, right? So synthetic division, x plus 3, that means this is x minus negative 3, right? So your c is negative 3. That's what goes in here into the synthetic division box. I got my line and then coefficients. That's 5, 5, negative 3, 83. What? Where'd that come from? 83 and 6. Yeah. This comes down 5. And then I got 5 times negative 3, negative 15. Negative 15 plus 5 is negative 10. Negative 10 times negative 3 is positive 30. Positive 30 plus negative 3 is 27. 27 times negative 3 is 90 minus 9 is 81. But with a negative. Add those together, I got positive 2. 2 times negative 3 is negative 6. And 6 plus negative 6 is 0. Winner chicken dinner. 0. What does that mean? Remainder of 0. That means it divided perfectly. No remainder. So no remainder. By the way, this also means that f of negative 3 would have been 0. Side note here. Yeah. But okay, remainder of 0 means it divided perfectly. So that means if it divides perfectly, then it is a factor. So what were we supposed to do? Decide if it's a factor. The answer is yes. It's a factor. Okay, that's number 7. Okay, that's it. That was number 7. Number 8, same thing. Now, number 8, I could repeat the same process, and I could. Wait, let me think for a second, actually, guys. Yeah, I could repeat that synthetic division process, do the exact same thing that I did for number 7, just check if the remainder is 0 or not. Or I can do it a slightly different way. I could just plug in the C and see if it works. So here I'm going to check f of C. Here C, this is x minus C, right? So C is the 4. So this is f of 4. So I take 2 times 4 to the 4th plus 3 times 4 to the 3rd minus 5 times 4 squared plus 10. So alternative way. So I could do the synthetic division and see if the remainder is 0. Or right now I'm going to check, is f of 4 equal to 0? If f of 4 is equal to 0, that means that it's a factor, right? It's a factor. 2, 4, 16, 64 times 4 is 256. 56, yeah. Okay. Already I'm starting to regret this decision. 4, 16, 64. Because now I have to do computation, which is my least favorite thing. But of course, you could just plug this all into a calculator. 2 times 256 is 528, isn't it? Yeah, 520. No. That's not right. 256, 512. 512, sorry. Okay, 3 times 64 is, what is that? Can't think right now. 2, 18, 19, 192. Okay, and it turns out I'm gonna have to check myself anyways because I'm not confident that I'm multiplying right now. 5 times 6 is 30 plus 50 is 80 plus 10. Okay, so 512 plus 192 is 704 minus 80 plus 10. 704 minus 80 is going to be 600 and is it 20 24? Yeah, plus 10, 634. Oh, is that correct? I don't know. Well, I feel like I might have made a computation error along the way, but this is clearly not going to be 0. Okay, because I'm not so sure, I'm going to check my work by doing the synthetic division after all. C was 4. I've got coefficients of 2, 3, negative 5, 0, and 0 is for the x term, right? And 10. I'm going to separate that. Draw my line, bring the 2 down. 2 times 4 is 8. 8 plus 3 is 8, 9, 10, 11. 11 times 4 is 44. Minus 5 is 39. 39, I still gotta do this. 39 times 4. Okay, this is looking like I made a computation error somewhere. 4 times 9 is 36. 4 times 3 is 24. 4 times 2 is 12. Plus 3 is 15. 26. Okay. So that's 26 down here. And 156 times 4. 4 times 6 is 24. 4 times 5 is 20 plus another 2. 4 times 1 is 4 plus another 2 is 6. 624. Oh, it actually was right. 634. Oh, look at that. Look at it. Look at me. 634. Okay, yeah. So anyway, the point here is that it's not 0, right? It's not 0. So is it a factor? No, not a factor. That was the point. And when you do these things, you don't have to do the computation by hand like I just did. Man, I'm surprised. Why did I do my computation by my hand? Why didn't I just bust out the calculator like a lazy person? Okay, number 9 and 10. Find the value of k for which x plus 3 is a factor of the given polynomial. Okay, this looks fun. I'm gonna go ahead and knock these guys out in this video. Should I wait? Actually, no, I'm sorry. I lied. I'm gonna cut it off because I want to have 4 videos and this is getting long.